Okay, this video is called Introduction to Logic, and logic just means the principles of correct reasoning. And there are two basic types of reasoning that we're going to talk about: inductive reasoning and deductive reasoning. Now, inductive reasoning is used to identify patterns. So, example number 1 in your notes, it says, let's say that every Friday so far this school year, the cafeteria has had chocolate chip cookies for dessert. Knowing that, what kind of dessert would you think the cafeteria would have this Friday? Well, based on the pattern that you've observed so far, every single Friday there's been chocolate chip cookies, you would probably reason, and this would be inductive reasoning since it's based on a pattern, you would reason there's probably going to be chocolate chip cookies for dessert this Friday. That's inductive reasoning. You identify the pattern and you use that pattern to predict what's going to come next. So this Friday we think we're going to have chocolate chip cookies. Now, a couple things to note about inductive reasoning. Inductive reasoning is not foolproof. That is, there's no guarantee, for example, that the cafeteria is going to have chocolate chip cookies this Friday. The truck that brings the cookies might break down. You might not have any cookies at all. Somebody might make a change in the menu and decide that they're going to have peanut butter cookies this Friday. So, there's no guarantee. Inductive reasoning is not foolproof. However, inductive reasoning often leads to something called a conjecture. And a conjecture is just a statement that is believed to be true, but is not yet proven. Now, we're going to talk a little bit more about conjectures as we go, but for now we're just going to note that inductive reasoning, you use it to identify patterns, and you use those patterns to make conjectures or to come up with statements that you believe to be true even though you might not be able to prove them. Now, a second type of reasoning is called deductive reasoning. Deductive reasoning starts with given facts and uses logical arguments to arrive at a conclusion. Now, these logical arguments are sometimes called the laws of deductive reasoning, which we're going to talk about some more in just a minute. And when we say arrive at a conclusion, sometimes this phrase, arrive at a conclusion, you hear people say, draw a conclusion. And that's just another way of saying arrive at a conclusion. So let's talk a little bit more about these logical arguments, these laws of deductive reasoning. There are two basic laws of deductive reasoning. The first one is called the law of detachment. And the law of detachment is a law that goes from something general to something specific. The second of the basic laws of deductive reasoning is called the law of syllogism. And the law of syllogism, we're going to also call the A equals B equals C chain, or the ABC chain law. And this law of syllogism, the reason we call it the A equals B equals C chain is because the law of syllogism can also be stated if A equals B and B equals C, then A equals C. So let's take a look at a couple of examples using these two laws of deductive reasoning. Example number 2. Our given statement, our given fact, it says all Americans are human. And then we're asked, if Kelly is an American, what conclusion can we draw about Kelly? Well, notice our given statement is a general statement about all Americans. Then we're given a statement, or we're asked about a very specific American, Kelly. Well, since we know that all Americans are humans and Kelly happens to be a specific American, the conclusion that we would draw is that Kelly must be human. Notice that we're going from a general statement about all Americans to a specific statement about a specific American, Kelly. That's the law of detachment. It goes from something general, all Americans, to something specific, one particular, one specific American. All right, example number 3, the law of syllogism. And remember, the law of syllogism we also call the A, B, C chain law. So our given statement here says all mice are mammals and all mammals are warm-blooded. And then we're asked, what conclusion can we draw about mice? Well, I'm going to rewrite these two statements here in a kind of math-looking way. All mice are mammals. Mice are mammals. Mice equals mammals. That's one statement. Then we have this other statement here. Mammals are warm-blooded. Mammals are warm-blooded. Well, if I think of this as mice equals mammals as A equals B, and if I think of mammals equals warm-blooded, mammals is my B statement, as B equals C, well then I can see I've got these two statements, A equals B and B equals C. Well, that means if mice are mammals and mammals are warm-blooded, my conclusion must be mice are warm-blooded, or A equals C. This is an example of the law of syllogism, the ABC chain. If A equals B and B equals C, then A must equal C. Now, you've got a few more examples on the back page of your notes. I want you to take a look at those. It asks you in each one of those examples what conclusion can be drawn based on the given information, and which law or laws of logic did you use to arrive at your conclusion. I want you to try those on your own, and we're going to take a look at those in class tomorrow.